Okay, it's 10 o'clock in California, so time to start. Hello and welcome everyone. Thank you for joining us today for this webinar. My name is Noémie Remilly and I am the event manager of SBG Systems. Today we are very excited to present you our new line of Ellipse series with this webinar entitled How SBG Systems brings the high-end inertial navigation technology in the miniature market. But while we still wait just a bit for the other, I will broadcast the new video we just released to promote this new product. The video is coming. Okay, so this was our video. I hope you like it. So I'm gonna introduce the speaker of the day. So we will have the pleasure to learn today from Thibaut Bonnevie, CEO and co-founder of SBG Systems, and from Alexis Guinamard, the CTO and co-founder of SBG Systems. Let's now have a look at the agenda. So in the first part, Thibaut will introduce the new Ellipse line. Then Alexis will focus on the INS GNSS technology, such as single and dual antenna, RTK, post-processing. And then Thibaut will conclude with the possible application for the new Ellipse series and give you some ordering information. And of course, we will have a Q&A session at the end of this webinar. Regarding the question, you can see you have a chat box on the platform. So don't hesitate to ask any question you may have during this webinar into the chat box, because we have a sales team and a support team that is working on the chat and that can answer your question live during the session. So don't hesitate, and we will also take some questions for the Q&A session at the end of the webinar. But before we start, we will have our first pull question. So it should be displayed on your screen now. Yeah. So the first question is, what is your application? So you can choose between air, land, marine, or if it's several of them, you can choose multi-industries. So I give you a few seconds to answer it, and then we will see together the results. Okay, I can see that nearly everybody has voted. I just wait a few seconds more for the last one. Okay. Okay, so I think it's quite mixed. We've got people from all kind of application today, so it's very interesting as Ellipse could be working with many applications. So we will now continue with Thibaut's part. So Thibaut, I give you the mic.
Thank you, Noémie. Welcome everyone. So I'm going to give you a quick introduction on SBG and go a bit deeper into this new Ellipse series, or third generation of Ellipse series. a bit too fast. So SBG Systems, so I guess a lot of you already know us, but I will be quick on that. So SBG Systems, we are a team of experts of inertial sensors. The company is headquartered in France. It's been operating for a bit more than 13 years now, with offices in the US and in Singapore to serve our customers in every areas. Our key focus is inertial navigation systems, mostly based on MEMS technology, so miniature products for orientation, stabilization, and navigation. We've got a large number of customers, quite well spread around the world, with a bit more than 700 customers in 40 countries, mostly in North America, Europe, and Asia. We've got now quite important feedback from our sensors in the field, with more than 25,000 systems used worldwide as of today. So the company is gaining more and more experience into the field. I'm not going to go too much in detail in our product, but just to give you a quick overview, our offer is ranging from IMUs, so calibrated sensors that provide you acceleration rate of turn for deep integrations. Our core business is our all-in-one sensors, of course, with the Ellipse that we're going to focus on today, but also the Equinox and the Apogee, which is our higher grade product lines. We've got some dedicated solutions for key markets, such as surveyors or LiDARs, with two main product lines here called NavSight for surveyors and Quanta for the LiDAR market. We've got a bunch of services around that to help you get up and running in no time. So it ranges from trainings, quick start, installation helps, but also warranty extension and all the services you can imagine around your product. And more recently, we've developed a range of software, the main one being our post-processing solution named Inertial. When you need to dive a bit more into your integration, or if you need to post-process a lot of data after missions, mostly during survey or mapping applications, to get those that are even more accurate than during the real-time application. If we focus a bit more on the Ellipse series applications, there are many applications, and I think the first poll question was quite reflecting that, which is very interesting. So, of course, we've got a lot of you involved in autonomous vehicles. Again, a large range of different unmanned systems, from UAVs, marine surface unmanned vessels, but also more and more autonomous cars, shuttles, mining, or agricultural vehicles. We've got a lot of survey and mapping applications as well, from small LiDARs to indoor mapping, aerial mapping, and so on. We've got growing numbers also of camera pointing and antenna tracking applications, both in civil and military applications. And of course, a couple of offshore and marine sciences applications as well. So before we dive a bit more into this third generation of the Ellipse, we wanted to take just a few minutes to reflect on the Ellipse 2 series. So the Ellipse series is our most popular product up to now. We've got more than 20,000 of those sensors on the field today. We have it for a couple of years with the Ellipse 1 that we released almost 6 years ago, and then the Ellipse 2. We're now at the third generation, which is really taking benefits of everything we have developed in the past on the Ellipse, but also a lot of development we have made for higher grade product lines that we were able to integrate into such small products. So what have been extremely interesting with the Ellipse and the Ellipse 2 series so far, and why it was quite popular when we are asking our current customers, their main answers are the technology is proven and robust. The product has been designed to be extremely robust for those miniature series, so fully sealed, dust and water resistant, but also extremely resistant to vibrations and fully tested in temperature to work in any kind of applications. We're doing quite regular survey with our customers as well, and on the Ellipse series, we're showing more than 95% of satisfaction on the product. So the team is working hard for that and is very proud of that. We've got a full technical support also that we're conducting now 24 hours a day with a technical support team based in the US, in Asia, and in Europe to cover any time zones. No export restriction, making it ideal to reach any customers around the world, and of course a 2 years warranty, which is probably the longest one you can find on a miniature product today. So that was the Ellipse 2, but we're now moving to the Ellipse 3, of course, and we are very happy to introduce a lot of new technologies that are going to make your project even more successful and even more accurate. So what are the main differences? We are still showcasing 4 main products into that series, from miniature motion sensors with the Ellipse A up to dual antenna GNSS INS system with the Ellipse D. 4 main differences compared to the second generation. The first one is a completely renewed processing part with a new extremely powerful 64 bytes microprocessor, which is allowing us to put extremely high-end filtering techniques that we are using so far in much higher-end products down to those miniature products. So the accuracy and the reliability of the system will be greatly improved. That is directly reflected on the pitch and roll accuracy, which is now going down to 0.05 degree, so 2 times better than the previous generation. We have also reworked a lot the GNSS part of those products, especially on the Ellipse N and on the Ellipse D, with now a full dual band RTK receiver built in those products, which is able to track satellites for all the main constellations. So of course GPS, but also GLONASS, Galileo, and Beidou. And those GPS are also able now to provide some raw data, which allow us to do some post-processing with Kinasha of those information. So that's the 4 main new functionalities that we're bringing to that product line. Which is why we're really pushing all the high-end technologies we used to see on our Equinox or Apogees into those miniature ellipses. But that's not all. Of course, they are already extremely small, but we can do even smaller packages. And so the Ellipse is also available now in some extremely tiny OEM packages, which are getting down to 17 grams for the Ellipse D, even less for the other product of the family. Extremely low power design for direct mounting and PCB. It's the perfect product for deep integrations when size, power consumption, and weight matters a lot. If we look a bit more in detail, so that's an export of the leaflet. You can get a lot more information of our leaflets and hardware manuals, of course. But you can see the main accuracy of the product. So of course, we're speaking about inertial sensors. So the 3 main aspects we're going to look at is pitch and roll accuracy, heading accuracy, and navigation. There are a lot more that you can discover into our different documentation, but that will be the key ones. Roll and pitch accuracy, we are now in real time getting down to 0.05 degree, as I was mentioning before. In post-processing, we can even be better than that, of course, because we have more data to compute and we're able to better track the errors of the sensors. The heading has been also greatly improved. Whether you're in single or dual antenna, we recommend, of course, dual antenna when you have low dynamics, and single antenna when you have larger dynamics. But Alexis will go more into details on that. So 0.2 degree is now what you can expect in terms of heading accuracy, which is much powerful than what we used to have on the Ellipse 2. Navigation, we are speaking a lot about the RTK accuracy, so the real-time kinematic, which allow you to go down to 1 centimeter of positioning accuracy. But of course, many of you will maybe not use a base station to go down to that centimeter accuracy, or may not need that. But even if you're using single point, which is extremely interesting with the dual frequency receiver we are embedding here, is that the single point accuracy is now down to 1 to 1.2 meter compared to a traditional 2 to 2.5 meters that we can see in single band receivers. So we're getting twice more accurate on that as well. Of course, for some of you that are involved in marine application, we are still computing heave. We are one of the very few miniature sensors to compute heave measurements, so that's allow you to implement the Ellipse series in applications such as motion compensation or voice and marine sciences. So if we look a bit more into main products that we have renewed here, the Ellipse N and the Ellipse D. So first, the Ellipse N, our engineering team has worked a lot to be able to put all those new functionalities and all those new electronics into the same form factor. So if you have been using some ellipses in the past, the Ellipse N is keeping the exact same form factor in box, is even smaller in OEM, but is now having all those added functionalities. So better pitch and roll, better heading, RTK capability, and dual frequency, of course. Same size, higher performance, but also a decreased price point and also decreased power consumption, which is quite important if you're running on battery, which is quite usually the case on UAV, for example. The one that has changed even more is the Ellipse D. So the Ellipse D used to be the big product you see on the bottom left part. We are now reducing a lot the size of that product. It's now having the exact same footprint as the other Ellipse products. So the size is pretty 4 times smaller than it used to be. But we keep that RDK capabilities. We increase the orientation accuracy, and we are now able to provide that dual frequency RTK receiver as well. So smaller size, smaller weight, smaller power consumption, because we're now down to 1 watt for all those capabilities, and also a decrease in terms of pricing. You can see on the right the OEM version. So I was mentioning before that it's an extremely miniature product that you can plug directly on the board. So you can see on the bottom side here, the small tiny connector that is going to be able to be plugged on your own PC. So that's it for that first part of the presentation. I hope that gives you a better understanding of the new capabilities that the Ellipse 3 is providing. It's been a pretty long work for all the research and development team, but we're very happy to provide you those new capabilities today.
Okay, thank you very much, Thibaut, for this presentation. It's now time for our second poll questions. Oops, sorry. I will try to reach it. Sorry. Okay, it seems I can't reach it right now, so it's okay. We will switch directly to Alexis' part. Ah.
No, there you go. You've got the.
Okay, okay. So yeah, okay, people can vote. Okay, I think it was just some latency. Okay, so the question is, do you plan to use RTK? So you have the choice between, I have no clue what RTK is. Yes, I need centimeter accuracy, or no, meter accuracy is enough for me. Okay, so I can see that about half of the people have already voted. I still let you a few seconds. Okay, 5 more seconds. Okay, so what are the results? Okay, so it seems that a large majority of you plan to use RTK, and as they need centimeter accuracy. What do you think of this, Alexis?
Yeah, that's very interesting to know that, and I'm happy that we introduced this RTK capability into the new Ellipse series. Thank you, Noémie. So I will now dive into a bit of technology. The first aspect I wanted to cover is showing the traditional way of fusing the inertial sensor data with other aiding sensors. So typically, in order to provide the position and velocity and attitude information, we use an IMU that consists in accelerometers and gyroscopes. We integrate these sensor data over time inside an INS box. And the idea is that this INS will suffer from drift because of these sensor errors, intrinsic sensor errors. And that's why we are using external sensor data like magnetometer or GNSS or any other third-party sensor like odometer or DVL or whatever information that we can fuse inside a Kalman filter. The Kalman filter will use both the INS information and aiding sensor to correct any drift on the INS. So in theory, that's very good. We have the IMU that provides a very precise short-term motion, and on the other hand, you have GNSS that stabilizes the position and avoids any drift. However, keep in mind that the EKF is not magic. If you want a good performance, if you want a good robustness, you still need to have a very good IMU. And also you need to have robust aiding sensors on the other side. The final accuracy you will reach is definitely driven by those two set of sensors. You need robust IMU operation. If you have any failure on the IMU, that's completely, your system is completely lost. And also, there is something that is not integrated into the Kalman filter, but many times you will see that GNSS information can be fooled, like in urban canyons, you have multipath, but you can also have jamming or spoofing attacks that could affect your GNSS information. And that's where we added a very nice piece of algorithm that is able to detect any faulty measurement on the GNSS side. So this is able to compensate any error on the GNSS. We are able to discard any invalid measurement. Now let's see how we can make a good IMU. I am really proud that at SBG we have a very unique expertise on the inertial systems. We have developed, as you might know, we have developed a full line of sensors, including the Ellipse series, of course, but also much higher grade units. And we developed a very, very high quality calibration procedure that is run over the full temperature range from -40 to +85 degrees Celsius. With this new Ellipse series, we could benefit of all the improvements that we've made for higher end products, and we integrated these improvements into this new Ellipse series. So in the end, you get better dynamic performance, but also on the heave side, it's improving a bit the heave performance. It's important to remind that all the sensor parameters are calibrated over the full temperature range, and you get an individual calibration report. That is a very good example that of our quality process. I am pretty sure that if you look at the calibration report, if you have some in the competing products, you will see that our calibration procedure gives much more details and a very high quality level. On the other side, it's very important to make sure that if we deliver one sensor, it behaves exactly as the next one. That's why we developed a screening process during the production. We make sure that all the units we deliver are within the specs. If you qualify your sensor during the prototyping, then you will make sure that during your production, you will also get the same performance level. That's the key. And you cannot do that without having a very high-end calibration procedure. So that's why at SBG, you have always an individual calibration that is performed over the full temperature range in these multi-axis rotary tables with temperature chamber. And finally, it's very important to make sure that you get a proper performance over the full product lifetime. That's why we selected only industrial grade sensors with ceramic packages. And also we have a very good expertise in qualifying the sensors. So we spend a lot of time, a lot of R&D efforts during the development phase to qualify the sensors we are going to use inside the products. And this makes sure that we will maintain the performance over the product lifetime. And as I explained on the IMU side, it's also important to have a good GNSS performance and a robust GNSS information. Traditionally, in the miniature product industry, we were all using single frequency GNSS technology that is already used in many applications. All the cell phones, automotive industry widely use this kind of GNSS technology. With a single frequency unit, you will be affected quite often by multipath effects, while with a dual frequency setup, you have more signals available. And that's really a key improvement in this new Ellipse series, especially on the Ellipse N and Ellipse D products, which have twice more signals to deal with. And they are able to cope with these challenging conditions like multipath, because with more signals, you are more able to detect which are the faulty signals and which are the good ones. Also, having quad constellations tracking is also helping a lot for this kind of issues. And finally, the dual frequency setup allows to estimate some atmospheric errors. So in the end, it improves the final accuracy. And last but not least, the dual antenna heading. It's a key parameter for your application. In case of single frequency design, there are some products on the market that provides dual antenna in a single frequency design, and these products need minutes of convergence in fully open sky environments, and they cannot operate at all in very difficult automotive conditions. So if you want to be able to get a robust heading in challenging conditions, then a dual frequency setup will be much better, and will be probably the only way to get a proper heading. Of course, the inertial will help, but you still need a robust GNSS. Now, this slide shows a bit information about RTK processing. So most of you showed that you know about RTK, but for those who are not so familiar with that, the purpose of RTK, which stands for real-time kinematic algorithm, the purpose of this algorithm is to provide a centimeter relative position between a base station, which can be your own GNSS receiver, or it can also be part of a network if you have a specific subscription. So you get a relative position between this base station and your rover sensor. In that case, it will be the Ellipse N or D. The GNSS receiver is going to use phase and range measurements and make differential processing between the base and the rover to provide a centimeter performance. So in real time, the main requirement is to have a communication link between the base and the rover. But if you can also cope with offline processing, you can also do it after the mission using Inertial post-processing software. And in that case, you will only need to download the base station data on one side and download the Ellipse data on the other side. So the communication link in that case is not really required. I now want to give you more insights about which product is the right for you. as you have seen, we have many types of products. We have the Ellipse A, Ellipse N, Ellipse E, Ellipse D. And all of these products do not have the same characteristics and same performance level in each type of application. So this slide tries to show for which application which is the best product. So if we start with the Ellipse A, which is the basic A-House product, we will mostly recommend it for lower dynamic applications, while if you have more dynamics, of course, we will suffer from performance from drifts or lower performance. And also, in case of difficult magnetic conditions, there will be an impossibility to provide heading. Of course, it will remain possible to provide roll and pitch in that case, but for the yaw angle, you will need an alternative solution. That's why we developed, on the first step, we developed INS products, which are able to cope with high dynamic application. Actually, the INS in a single antenna are best suited for high dynamic applications. They can also cope with lower dynamic, but in that case, the single antenna product will remain limited to magnetic heading. And in case of difficult magnetic conditions, you will only operate in case of dynamics. And if you want a product that works in all these challenging conditions, the Ellipse D will be probably the best product. Thanks to a dual antenna heading solution, we will be able to work with both low dynamic applications, but also higher dynamic application, and with a full immunity to magnetic disturbances. Now I want to show you some test results. Of course, we've done a lot of tests during our development, and the product is also being tested at the moment by several early adopters. So in this scenario, we did a very typical land scenario with a lot of medium to high density urban environments. There is here also a 1 kilometer long tunnel that we travel in both directions. So there is a mix of let's say good conditions and very challenging conditions in this test scenario. We ran the Ellipse D in dual antenna setup in two modes, one with the automotive motion profile, which is really best suited for the automotive applications because we can use the some specific constraints to limit the drift in case of GNSS outage. And in that case, we could reach a very nice performance level in comparison to a higher end reference system that was post-processed. We exceeded the specified performance level on the roll and pitch, which was completely amazing given the challenge of the urban canyon that we were facing. Also on the yaw angle, we were completely amazed by the results that were better than what is specified. And finally, the position was also very nice, considering that we could not have full RTK solution all the time. Of course, in the challenging conditions, the RTK fixed mode, which means that you've got your centimeter level performance is not always achieved. But most of the time we were under 10 centimeter, 98% of the time. And even in airborne motion profile, which cannot be helped by automotive constraints, we were also exceeding the performance specifications on the roll and pitch, but also on the yaw. On the yaw angle, we were behaving very nicely. And even in the position, we were 97% of the time under 10 centimeter error. So that's really amazing. And we have other results that show very similar performance And so that's why we are really confident and proud of this new Ellipse series. And to finish my part, I wanted also to introduce you how you can make use of Inertial. Some of you might know a bit of Inertial. It is a post-processing software which is traditionally used to get the ultimate performance of your inertial sensor, thanks to a forward, backward, and merge processing. This is widely used in the survey industry to get the best of the inertial sensors. So Inertial is widely used for this kind of application, but for the Ellipse, there is also a possibility to take a very great benefit from it, also in the real-time applications, by analyzing any data that you have logged, but also to optimize the real-time performance. Because you can rerun any log that you have recorded, you can replay sensor data with different configuration, for instance, but also the most important is that you can refine any GNSS lever arm setup that you entered in the sensor configuration to improve the performance of the system. Inertial is able to estimate at about 1 centimeter the distance between the IMU and the GNSS antennas. And thanks to that, by entering these refined settings into the sensor, you will be able to greatly improve the real-time performance. And that's it for my part. I will now let Thibaut continue with the applications.
Thank you, Alexis. So I'm going to give you a quick overview of 4 main applications that we have selected for this new Ellipse series. So, of course, the first one that we can think about is unmanned system navigation. What is important for unmanned system navigation is when we ask our customer base, 2 things that we see most of the time as answers is first the accuracy of the navigation data, but also the reliability of the navigation data. So this new generation of Ellipse series has really been designed with that in mind, and that's why we took great care about the GNSS side. We're also implementing in combination with our inertial sensors. So now the fact that you have quad constellations that are used and run in the algorithm at the same time, the dual frequency and the RTK capabilities are really bringing you that accuracy and redundancy of signals to make it reliable over time. Of course, there are also some scenarios where you need some specific capabilities. For example, if you need to operate in low dynamic application, as Alexis was explaining before, you might need some GNSS heading to make that more accurate during those low dynamic phases. And that's where this new Ellipse D, especially with its tiny OEM form factor, can really enhance your application. In the past, dual GPS antenna, dual frequency was quite heavy, quite big, so that was not really a possibility to embed that into a UAV application. Now you can with the Ellipse for generation. Last but not least, we also try to make it as easy as possible to integrate in all your applications. So of course, we provide software libraries and all those kind of things to help you, but a lot of your applications are using ROS, the robotic operating systems, and we have developed drivers for that. So you can go on the ROS website and look for SBG and the Ellipse, and you will find our drivers directly on it. It's documented, it's keeping up to date by our team, and it's used a lot by the community. So you will see a lot of different usage of that already implemented into ROS. More drivers are going to come over the next few months as well. So if you want to stay updated on that, make sure to be in touch with our sales team or with our newsletter, and we'll keep you posted on that. The second quite fast-growing application we do see as well today are all the land autonomous vehicles, both commercial and industrial. So we put under that all your autonomous car application, trucks, shuttles, mining vehicles, tractors, any of those. Here, same thing as before, the accuracy, of course, and the robustness of the position is key, but there are some specific needs that we have implemented over time. The first thing is CAN bus. A lot of those automotive applications use CAN as a reference communication system. So we have that on the Ellipse, and we're probably one of the extremely few mirror sensors to have implemented CAN. We are also able to fuse odometer data, so the wheel speed of the car, to get more accuracy when we're losing GPS. So if we're going into urban canyons or under tunnels, to keep your position as accurate as possible. With the Ellipse 2, that was possible to take pulse odometer. Now we can also take the odometer from the CAN bus. So on a car, for example, you have usually an ability to plug where we can find those information, so we can get that directly from that source. And we have also implemented more recently some dedicated outputs for car testing, such as slip angle, curvature radius. So we're really trying to bring all the few functionalities that are really dedicated for that market. Of course, integrating with other systems is key. So CAN bus is a plus, but a lot of customers are using ROS or the different automotive version of ROS, such as AutoWare and so on. But a lot of our customers are also using Ultimaps as a software to grab all their information from LiDARs, cameras, radars, and inertial sensors, of course, and fuse all those data. From the very beginning of Ultimaps, the SBG sensor has been implemented in it, so you can very easily grab all those information and use them into your softwares. The next one is everything around antenna and camera pointing. So it could be both military or civil applications. A lot of that might be military, so we tried also to focus a bit on that. So here, dual antenna will be a key element to have a good accuracy of the antenna pointing. So that's something that we are going to do mostly with the Ellipse D. Quite constellation and dual frequency is also key to make sure that whatever happened, your signal will be able to detect any spoofing or any interferences, as Alexis was describing before. We also have a quite flexible design with the range of INS we have on the Ellipse, and we can integrate some external GNSS receiver, such as military grade, so SASM receivers. And of course, an important part is also the full calibration we're doing from -40 degrees to +85 degrees Celsius to be able to cope with any military environment you may be facing. And we're trying to cope with most of the military standards, especially the MIL STD 810, which is quite important on that application. Of course, as we were seeing at the beginning, we also have some marine customers with the Ellipse. A lot of different scenarios on that marine applications, but the key things here might be either motion or navigation. And when we're speaking about navigation on boat, the dynamic is very slow, so the dual antenna heading will be key. Heave measurement is also an extremely important functionality for that market, and we are able to provide a 5 centimeter heave. It's especially suited for shallow water or inland water. Of course, you're not going to survey in very deep water with an Ellipse series. For that, we have some dedicated product lines, such as the Equinox, the Apogee, and NavSight. But for single beam or side scan, echo sonders, and a variety of marine sciences application, that's going to be an ideal solution. So that's it on the application. Of course, there are many more applications that we can go in details, and feel free to contact us to discuss more your application. But that was the 4 key ones we wanted to mention today. To end, a couple of ordering information. So of course, the sensors are great, but you expect probably a bit more than sensors from SBG. So when you get started with the device, you're able to also order a development kit where we're providing all the needed reference documentation, all the needed accessories, antennas, if it's an OEM product, development boards as well, all the tools to be able to configure, visualize and analyze data easily, and also export data to your different data acquisition systems. So that's for us the SBG Center, and of course some libraries and code examples. Also, because you have a wide range of different applications, GNSS antennas might be key also to get the better accuracy possible. So we are providing part of the development kit some general purpose antennas, which are extremely accurate, and that's the one that were used in the test that Alexis was showing before. But depending on your application, you might want after that to go to more specific antennas. So we have selected 3 of those to be able to cope with all your application: a patch antenna, which is high performance mostly for land applications, an helical antenna, which is more designed for UAV applications with its very small footprint and no need of ground plane, and of course a marine antenna, which is waterproofed. So whatever the application is, we will have an answer for that. It also comes with a range of services to get you up and running in no time, and to get you also supported during all your integration period and even after that. So of course you get an immediate free firmware upgrades. Also you get access to our support engineers in the US and in the other areas if you have to call at extremely early mornings on the East Coast or pretty late on the West Coast. Our teams around the world will be able to support you both by phone and emails. And every products that we are shipping are coming with 2-year warranty, so you don't have to care about your sensor for quite a long time. So to sum up the series, we keep it as small or even smaller than the 2nd generation, but we add a lot of new functionalities to it. So we now have an extremely miniature products with big features that we were seeing more into extremely large and expensive products in the past. When will you be able to get deliveries of those? So on Ellipse D, both box and OEM, we have started delivery. So products are already reaching customers as we're speaking. Ellipse N, Ellipse A, and E are coming in more volume in September. So you can start testing them, integrating with all the documentation, but the production will ramp up in September. And more specifically for the OEM version of the Ellipse A and E, the production will ramp up in Q4 of this year. So most of those sensors are already available or will be available at the end of the summer, and those specifically OEM products will come a bit later during at the end of the year. That's it for our Ellipse presentation today. Thanks a lot for your time, and I will give the mic back to Nomi.
Yes, thank you very much, Thibaut. So it's now time for our Q&A session. Let's have a look to the question you have asked in the chat box during the session. Okay, so first question. How long does it take to achieve performance from startup?
Okay, I will take that one. That's a good question. Actually, all the inertial systems on the market will have some what we call a warm-up time, which is required to refine all the bias estimations and all the different states that we need to estimate in our Kalman filter, but also to warm up the sensors in a real temperature way. There is a possibility with this new Ellipse product to reduce a bit this warm-up time by fixing the lever arms. If you measured it very precisely, the system will be able to account for really precise lever arms, and it will help to reduce this warm-up time to obtain the full performance. So typically, we expect a few minutes of convergence time. During this time, you can have a look at the standard deviation outputs that will give you a good information about the actual sensor performance. And it's very important to remind that during this phase, the sensor is completely usable. You can rely on the sensor data up to the standard deviation extent. So it means that it's completely possible to use the sensor during the warm-up time. The only limitation that, will be observed if you have a GNSS outage. You might suffer from a bit faster drift during this warm-up time compared to once the sensor is completely aligned.
Okay, thank you, Alexis, for the answer. We have a second question, which is, what do you recommend for LiDAR integration?
So I might go on that one. So of course, the Ellipse, with its extremely small form factor, accuracy, and also dual antenna capabilities, is a perfect candidate for fusion with LiDARs. Also, most of the LiDARs are recurring pulse to be synchronized that the Ellipse is providing. It's usually a product that we see a lot for autonomous vehicles, especially with small LiDARs, so the typical Velodyne or Ooster or other similar LiDARs. When we're going more to survey and mapping, if we're ranging to higher altitude LiDARs, then we might go up to more accurate product lines. We've got one especially designed for LiDAR integrators, which is called Quanta, with different level of IMU accuracies. But for everything which needs to be tiny, small, and extremely integrated, the Ellipse, both as a box or an OEM package, will be extremely suitable for it. Yes.
Okay, thank you, Thibaut. Next question: how do you interface to the OEM version?
I will take that one. So there is I think on the picture we might have seen that there is a tiny PCB board-to-board connector on the bottom of the OEM enclosure. So we developed the OEM versions with a very small aluminum enclosure to make it very robust to mechanical stress, for instance. But still, it's designed to be mounted directly on a PCB.
Okay, following question. Regarding the calibration, will it come with one-time calibration? Is there a need for recalibration in the future?
As Alexis was mentioning before on the calibration part, that's something that we focus a lot at SBG. We really think that extremely well-calibrated sensors will deliver the best accuracy over time. So calibration is key, but also the sensor selection is key. We don't speak too much about that, but every MEMS sensors we're using on the Ellipse are ceramic packages, which are extremely slow drift over time. So the calibration is done in factory. There is no need of recalibration during the lifetime of the product. After that, it comes with extremely detailed calibration report. Of course, some of you for specific needs because of regulations or because of internal policy, we've got a few requirements every year of check and recalibrations. Those are some service we can provide, but the product doesn't need it over its lifetime.
Okay, thank you. Another question is, do I get full inertia PPK with my Ellipse D?
So with the Ellipse series, we have a dedicated version of Inertial, which is called Inertial Lite, which provide all the functionalities of Inertial, but is limited to the Ellipse product line. So that allow you with at a smaller price point to be able to post-process everything. For some of you that already use some higher-end product for SBG and that have a full Inertial Pro license, of course, those new Ellipse are completely able to be post-processed into Inertial Pro. But if you're new with Inertial, you don't need to push that Pro version. The Lite is perfectly fine, and it comes with two different ways of subscribing. So either you can pay for a monthly or yearly subscription, or you can buy a full license. Both are possible. It really depends on your needs. We usually see two different way of using Inertia, either during your test and development phase, where you need to make sure you have the right setup, you need to assess your accuracy, and for that the monthly subscription is perfect. If you're more surveyor and you need it in the long term to post-process all your data in combination with LiDAR or with sonars, then the full license will be a better choice.
Okay, thank you. And one last question, I guess. Is the Ellipse series suitable for hydrography and bathymetry applications?
That's a good question. It's a question we often have. So it's not the product line we're dedicated for that. For that, we have an offset which is really dedicated for a multi-beam and hydrography application. But we have many customers using the Ellipse for those applications as well. You can find many integrators, single beam or set scan manufacturers that are integrating already the Ellipse into their systems, and of course a lot of end users that are doing that as well. So it provides HEAV, it provides now RTK data, so it's a good choice for lower end system where you need motion and good position reference. We have some drivers for most of the reference softwares of that market. So we've got drivers, of course, for HiPAC, for Quincy, for PDS. So it could be a good solution for shallow water and for single beam and side scans.
Okay, thank you. Thank you, Alexis, Thibault. I think we will end our Q&A session here for today as we are running out of time. But don't worry, if one of your questions hasn't been answered during this session, either in the chat box or during this Q&A session, we have noted all your questions, and we will come back to you by email in the coming days to answer them. Yeah, so this webinar is now coming to an end. We would like to thank everyone for joining us today for this hour. We hope you enjoy this webinar as much as we enjoy preparing it. For your information, you will receive the recording of this webinar tomorrow. So if you want to replay it, you can. You can now see on your screen the contact detail of our different teams. You can read them by email, our EMEA team, North America and Asia team. And you will also find on our website our very wide network of local dealers. So don't hesitate and have a look on the website. And also at the end of this session, you will have a small survey that will appear on your screen. So please answer it because, for example, it will ask you if you want to be contacted by a sales rep or not. So it could be useful for us. So thank you for joining us today. Have a good day or good night. And in the meantime, take care and talk to you soon. Thank you. Bye.
Thank you, everyone.